Beneath the surface, Sonia Dara stands in a hallway lined with electrical cabinets.
Hello and welcome to Beneath the Surface, the show where we look at what's new, what's cool, and what's happening in Surface. I'm your host, Sonia Dara, and today we're coming to you from Building 87 on the Microsoft campus, where we house just a fraction of our quality and testing labs. To show us around today, we're going to meet up with the VP of Device Quality, Ricardo Lopez-Barquilla. And I don't think you guys understand how cool this episode is. We have never, ever filmed in these labs before. We're really taking you beneath the surface right now.
A slender robotic arm descends toward a touchscreen, tapping it repeatedly with a cylindrical, finger-like pad. Sonia steps into a testing lab.
Whoa, this is such a cool room. Hey, Ricardo.
Hey, Sonia. Welcome to the Touch Lab.
Oh, this is so cool. Thank you so much for having me.
Very excited to have you here.
Awesome. So to kick things off, I was hoping you could tell us a little bit more about yourself and what your team does.
So our goal is to make sure that we ship high quality devices, innovative high quality devices, and thinking about quality as the device disappearing. We want you to pick the device and be able to complete what you are doing, what you are writing, what you are thinking, without the device basically being there.
Right.
So being the perfect tool.
I love that. And so you said this is the Touch Lab. I'm seeing a lot of things being touched right now.
Yeah.
What's exactly happening right now?
So touch and pen is such a critical part, such a core part of what we do in Surface. So this is the touch and pen lab. And here, think about handwriting. It's such a human, natural thing. We want you to take advantage of all the great things about digital ink,
Right.
but you can have all your notes for 10 years ago that you can search them, that you can carry, you can copy them, without needing to change the way you write and being still a beautiful handwriting.
Right. The importance of also the hardware and software coming together.
Yeah, that is critical, because at the end, in something that simple, there is so much hardware, so much software, from the chip that we build to all the algorithms. When you have real ink, you kind of smudge your paper. This is not smudging with this, but we have beautiful algorithms that remove your palm, so it looks like basically you are writing on a paper, better than on a paper.
A mechanical arm writes in cursive.
Whoa!
A Surface Slim pen writes
It has
hello.
better handwriting than me.
Yeah, this is Jenny's handwriting.
How do we achieve this and really make it a great experience?
With a bunch of experts that you see here, with a bunch of robots, and with a lot of work and a lot of sessions of tuning till we get to a better experience, the perfect experience, and then we keep going to basically get a great device.
Awesome. So this lab is helping test out some of those experiences. Is there anything we can maybe
I can
see?
show you a very cool demo. You want to see
yes,
it?
I'm
Let's
down
go
right
and take
now.
a look.
All right.
2 racks hold 20 Surface devices connected with cables. A montage of photos in the lab.
Okay, so it looks like we're in a new lab. Very, very big lab. Lots of secretive stuff over here, it looks like. But where are we now?
So this is the thermal lab. Another way in which we want the device to disappear is we want the device to be cool to the touch, and we also want to be performant. So in order to do that, the only way to do it is to have software and hardware very tightly coupled, tightly integrated. So we go from the selection of the materials to how we design the motherboard.
Can you tell us a little bit how these chambers are working, though, and how they're testing that?
So these are natural convection chambers. So basically, on these chambers, we can go through a lot of different temperatures. And what we do is we basically get all these devices, we get a lot of thermocouples to them, basically to measure what is the temperature, not only outside, but also inside.
Right.
We get, in some of these devices, we get even to put 40 to 50 thermocouples, and then we figure out what is their temperature as we are running a lot of different automated scenarios. So we do thousands of Teams calls, we play a lot of games, all the things that we think that the people are going to do with these devices.
Great.
As we were saying before, trying to make the device disappear, try to make the device that is just something that you pick, you want to do something, you grab it, you stay in your flow, and do your thing, and you're done.
Oh, that's awesome. That actually reminds me, I've heard now about all these different factors, and heat and temperature, but any other invisible factors that we as consumers just aren't aware of that you're actually testing for?
Yeah, at the end, we want to make everything invisible. People that are watching this video, they will only think about audio if they cannot hear, or if the sound is not clear, or if somebody says, look, I cannot hear you when we are talking in Teams. So all that is another aspect of, we want to keep that hidden. We want to basically get people to just talk on Teams or watch this video, not worry about the audio, their speakers, or their microphone. We want to hide all that.
So your team is working on minimizing those impacts and mitigating them and fixing all those. That's awesome.
Cool. Do you want to see more things? We
I
have a lot
would
of
love
things.
to see more
Okay,
things.
let's go for it.
Let's go. All right, awesome.
A montage of dozens of Surface devices on shelves, several displaying color grids across their
This
screens.
is one of the rundown battery labs. So here is where we characterize the rundown for all our devices, the battery life of our devices.
Right.
And what you can see here in all these devices is they are running a lot of different scenarios. We have devices that are sitting on desktop idle. We have devices that are running PowerPoint. We have movies there that we have. And that movie is a specific movie that it has a high dynamic range in all aspects. We have animation, we have actual live action, we have darkest scenes, widest scenes. So it's everything in one movie. And we have used that for years.
So it's running essentially the average experience across all the telemetry that you've pulled in. And optimizing that and just running down these batteries over and over and over again.
Yeah, and if you look at, and we apply those learnings from telemetry, we know what is the average number of tabs. So the web browsing experience, the web browsing battery life is the one that we are expecting to have.
Oh, that's awesome. All right, what's next?
So let me show you the inside of the devices. We have seen a lot of full devices. Let's go and take a look at the
We're
inside
gonna
of
look
the devices.
inside.
A montage of circuit boards, tools, and clamps. Sonia leans toward a microscope connected to a monitor.
Oh,
This
wow.
is the inside of a Surface Duo, the Surface Duo 2. So this is one of the 3 motherboards that you see.
So cool. What's everything made?
But you're not going to be able to see that much there, but that's why we have this microscope.
Oh,
So
thank
what we do here is do all the reworks here. In the same way I was telling you about this tuning, this iteration,
Right.
this fast iteration. We do that with the in software. We do that with hardware here. If we need to do any of the reworks, we come here with this microscope and take a look to that. So take a look and you will see.
She peers into the lenses.
And of course,
Nice,
now
that's
you're
it.
an expert, so you know exactly what you're looking at.
Yeah, there's the Qualcomm chip.
So if you
Yay.
find any problems, let us know. Although this
Oh
is
yes,
already...
I totally see that. Oh my God, my fingers look so big.
A magnified view appears on the monitor.
That was the problem area. Squeezing in a lot of components into a very, very tiny.
We were talking about the mechanical part of it because at the
Right.
end, our devices need to keep having this great build quality. And this idea of the component, of the tuning, we do it in software, we do it electrically, but also we do it mechanically. And that is how kind of my team is involved. My team is involved from the very early. When we think about something like the hinge, for example,
Yeah.
we start by understanding how people use the device. What is the percentage of time that the device will be in this position, in this position, in these positions? What will be the forces? How would people
Where?
open the device? How many times people are going to open the device? How many are going to close the device? And when we have all that and that understanding, we model that. You don't want to think about the hinge. You just get your device, you put it here,
Use it.
and it's great. It's not your angle, you move it. You don't
Yeah.
think about the hinge. You just think about something that you wanted to achieve and you are achieving.
Yeah.
Do you want to
Oh.
see a place that has a Guinness record?
A Guinness record?
Yeah, let's
Oh,
go. Let's go and take a look
yeah.
to that.
There's a room here with a Guinness record?
Yes.
A montage of production crew images. Sonia steps inside an acoustic chamber.
Whoa.
So welcome to the quietest room in the world.
Okay. All right. How and why do we have the world's quietest room in Microsoft?
So when you think about the device disappearing, there is nothing more painful than hearing this faint noise when you are working at night. And this is the place where we are able to detect that early and we are able to eliminate it. And why this room? Because no matter how quiet your room is, this room will be quieter. And this building is built around this room. So this has its own foundation. It's separated from the building, as you have seen, and it has a 12-inch concrete walls all around it. And right now we are sitting on top of a bunch of springs.
Yeah.
So no matter what happens outside, we are not going to be able to hear anything. Also, these things are able to eliminate any of the reflections.
Panels.
That's amazing. Honestly, I've had such a great time seeing the 5 labs today. It's so amazing.
Yeah, and those, you have seen 5, we have 300 labs in Redmond and nearly 80,000 square feet. And we have labs all around the world. And all this is basically the evolution of when we are finding things, when we are seeing that we want to get farther into the tuning of the device, or we are seeing problems that we want to eliminate.
Yeah.
And that is in labs, and that is in everything that we do. We have test. We have AI-based automation now that looks at devices, that looks at the screens and try to find problems, try to find glitches. All those things are happening. So when you come in 5 years, you will be able to see something very different.
Ricardo, thank you so much for showing me around the labs today. I've had such a great time.
It was super great to have you here. You are welcome to come anytime you want.
Thank you. I love
But
this room.
before you leave, you need to experience this. It's pretty cool. If you stay here 15 minutes and turn off the light, you will start heating your own blood through your veins. So I think you're gonna enjoy that. It's well, some people hate it, but some people think it's great.
Did
So
you
I think
say I'll hear my own
I think you're
vein?
gonna I think you're gonna love it. So
Oh my God, what is happening?
He shuts the door.
Okay. I'm not sure. You guys are joking, right? Oh, wait, you were serious about turning off the lights?
Well, I hope people like and subscribe.
Microsoft Surface.
They're gonna come back for me, right?
Microsoft.
Ricardo?